Hey guys, so today we're going to be talking about distance/time graphs. So if you remember last week we talked about distance and time. Distance divided by time is speed. So these graphs will also allow us to calculate the speed. Let's just go ahead and get started. So a distance time graph shows an object's motion. It shows how long it takes an object to travel a certain distance. So we can see on our graph here that the distance is our y-axis and the time is our x-axis. So if we calculate how long the object was in motion, which we see here that it stops at 16 seconds, or 16 hours. So it traveled for 16 hours, and how long did it go? Or how far did it go? So it went all the way up here, which is 14 kilometers. So to find the speed, the average speed of the object, we would do distance divided by time, which is 16, and we would figure that out, and that would give us a decimal. So these graphs are showing us the speed, but they're also showing us the distance in hours, and each section of the line shows something else, and we'll go through that. So what can you calculate using distance and time? We can calculate speed, and that's what we just talked about. We look at the distance, which was 14 kilometers, and we look at the time, which was 16 hours. So using distance and times graphs, we can look at them, and a straight line shows an object moving at a constant speed. So when you see a straight line, these lines, all three of them, the yellow, the blue, and the pink, they're all straight. So that means that these objects, all three objects, are moving at a constant speed. The steeper the line, the faster the object is moving. So if you look at our little key up here, we have the pink line is definitely pointed more down. It's not as steep. So this is the slowest one, is the pink line. The blue line, the thick blue line, is a little bit more steep than the pink. So it's moving at a constant speed of a little faster, but this yellow line is steeper than all of them, so it's the fastest speed. If I had a line that was pointed like this, it would definitely be the fastest. If I had another line that was like this, it would be the slowest. So the steeper the line, the faster the object is moving. And that's because if we look at, so let's look at our pink line. Our pink line traveled 10, this is the distance, we represent with a D. The pink line traveled 10, let's just say 10 meters, in how many seconds? 10 seconds. So 10 meters divided by 10 seconds would give me 1 meter per second. So if we look at our yellow line, the yellow line traveled 30 meters in 10 seconds. So if I divide these, that would mean that the yellow line was 3 meters per second. So we know that 3 meters per second is faster than 1 meter per second. So that's what those lines mean when they are steeper than the other ones. All right, so which object is faster? So our red line, first we need to look at the distance to calculate the speed, because faster means speed. So I'm going to represent that with an S. So our red line, a red mark over it so we know that's what we're talking about. It went a distance of 30 meters. So distance divided by how long did it take? 5 seconds. So 30 divided by 5 would be 6. So it went 6 meters per second. That was our red one. Erase this stuff. Our green line went a total of the distance. I'm going to go up here. It's about right here. I'm just going to put it on 30 as well. So it went a total of 30 meters. Make sure you put that so you remember. 30 meters in how many seconds? 15 seconds. So 30 divided by 15 equals 2. So this one traveled 2 meters per second. So which one traveled faster? A, which is the red one, or B, which is the green one. So the red one went 6 meters per second, and the green one went 2 meters per second. So which one is faster? It would be A. And we could look at this without even calculating, because that red line is steeper. The red one is steeper, so that means it went faster. But I just wanted to calculate to show you as well. So we talked about the steeper the line, the faster it goes, and it says work out the speed for each object shown in the graph, and we actually already did this. So a stationary object, a flat horizontal line, shows a stationary object. So when you have a line that is just straight on any part of your graph, that means the object did not move. For example, if I'm running and then I stop, when I graph that, you're going to see a flat horizontal line for how many seconds that I stopped. And then if I start again, then you will see the line go a different direction. But if you have a straight horizontal line, that means the object did not move. So this means the object is not moving, and time keeps moving, but the distance stays the same. And we can see that here. Our distance, all these are distance, is 10. And from 0 seconds to 9 seconds, my distance did not change. It stayed at 10 meters. So that means the object did not move. All right, so accelerating objects, we can look at accelerating objects as curved lines. So curved lines show if an object is accelerating or decelerating. So the steeper the line gets, the faster the object is moving. The steeper the line gets, the faster the object is moving. So I am accelerating here. First, I'm kind of moving at a constant speed. Then when you have these little curvatures right here, that means that your speed might have been 1 meter per second, but it's curved up really fast, and now the speed has changed. So you went from maybe 1 meter per second to 3 meters per second. Within here, and then that little dip shows acceleration. So there's also changing direction. So what is happening between C and D? So if we look at C and D, you might think that this object is slowing down, but that's not what that means. It means that the object changed direction and is heading back to the starting point. So let's pretend I'm a little jogger here. I'm jogging. From A to B, I am going, so I went 60 meters in 30 seconds. So I'm going to go ahead and find the speed from A to B. So you can see that I went 60 meters in 30 seconds. So I'm going to do 60 divided by 30, and that will give me 2. So right here, I'm going 2 meters per second. And then from B to C, I have a flat horizontal line. So that means from 30 seconds to 50 seconds, I did not move. So I have not moved. But then from C to D, you would think that if the line is going down, that you would be decreasing speed or something along those lines. But all that means is that I'm a jogger, I'm running 2 meters per second. I take a break here and turn around and go back to my starting point. So we can calculate the speed from C to D as well. So at my distance, I'm going from 60 to 0. That is still 60 meters. I've still went 60 meters, even though I'm just turning around and going in the opposite direction. And I went from 50 seconds to 70 seconds, which that is 20 seconds. So actually, I am going 3 meters per second on my way back. So I'm actually going faster. So even though that line is sloped down, all that means is that it is changing direction and you are going back towards the starting point. Oh, here, a jogging graph, perfect. So describe the motion of the jogger in each section. So we said that from A to B, the jogger went 2 meters per second because it went a distance of 60 in 30 seconds. And then from B to C, the jogger did not move. So he is taking, or she is taking a break. So we're just going to put taking a break. And then they turn around. So at C, they turn around. And now they're going to start jogging back to their starting point. So we said that the distance, we have 60 back to 0. So that is 60 meters. So 0 to 60 is the same amount of meters as 60 to 0. And we're going to find the speed by dividing it by the time. So at 50, they turn around, 50 seconds, they turn around and start jogging the opposite direction. So from 50 seconds to 70 seconds, which that is 20 seconds. So our speed is 3 meters per second. All right. So let's look at some graph questions. This is a man, this graph represents a man walking his cat. So number 1 says, what is the speed of the man during the first 3 seconds? So, let me get a brighter color. Well, that matches that one. Let's get green. So during our first 3 seconds, we got 1, 2, 3. This is my time on my x-axis. What did he do during the first 3 seconds? Well, what was his speed? So I'm going to go ahead and draw a line here down to 3 seconds so I can know where my distance is. So my distance at 3 seconds, I had gone 12 meters. So then speed, represent that with an S, is 12 meters divided by how many seconds? 3 seconds. 12 divided by 3 equals 4, and we have meters per second. So his speed during the first 3 seconds was 4 meters per second. Number 2 says, what is the man doing between 3 and 5 seconds? So, change my color. Here we have 3 seconds, so I'm going to draw my line up. It's right here. And then here we have 5 seconds. I'm going to draw my line up right here. So we have a flat horizontal line. So what is this man doing during these 3 and 5 seconds? He is not moving. He is standing still, or not moving, or taking a break. So number 3 says, calculate the speed of the man between 5 and 7 seconds. Let's do pink. Okay. So between 5 seconds, I'm going to draw my line up so I know, between 5 and 7 seconds. So I know that he is at 12. So all he is doing right here is turning around and going back to his house. So at 12 seconds to 0, or 12 meters to 0 meters, that equals 12 meters in all. So how much time do we have between 5 and 7 seconds? So we have 2 seconds. So all I need to do is do 12 meters divided by 2 seconds. So that would give me 6 meters per second. So he's actually going a little faster on his way back home. So what is the total distance that he has moved? So let me erase all my markings and I will show you how to figure this out. To find the total distance. You would think that the total distance is 12, right? But that would not be correct because he walks 12 meters, then he stops, and then he goes back home another 12 meters. So his total distance would be 12 meters plus 12 meters, and that will give me 24 meters. So the total distance is 24 because he goes from point A to point B, stops, and then comes back to point A. So that is 12 meters there and 12 meters back, which gives me 24 meters. Let me go back one. Oh, that works. Okay. So, just to review what we went over, a straight line that we have here. This straight line is, no, not a straight line. This straight line at an angle, so a straight line at an angle is a constant speed. The steeper the line, the faster the motion. So we have a line here, and then we have a line here that is way steeper. This would be the faster speed. Next one says a flat line equals stopped or stationary, not moving. So a horizontal flat line like this means that you're stationary. You're not moving. A curved line means you're accelerating or changing speed. So you're accelerating here. If I had a line that was more like, so I was at a constant speed, then I stopped, and then I went down, and then went like this, that would be decelerating. So that would mean that I'm slowing down. But since the line is angled like this, that means I'm speeding up. So slope down, when we have this line that is going back to the starting point, that means you're returning to the start. You're just changing direction. It doesn't mean that you're slowing down. You are just changing direction, going back to the start. All right, that is all I have for you guys today. I know that was a lot, but we will keep practicing this week and get better at it. Okay. Thank you. Let me get out of this. Okay, and